Okay, so now we are trying to focus on next topic in AGRP protocol. Wait. In AGRP protocol, we complete our unequal cost load balancing concept. Unequal cost load balancing. We can install other routes forcefully in routing table. This is called unequal cost load balancing. Now let's talk about today AIGRP stub concept. Remember OSPF stub concept? In OSPF, we have same topic. OSPF stub, OSPF total stub, OSPF NSSA, not so stub area, and OSPF total NSSA. But here story is different. Story is different.
Okay.
Okay, if you talk about OSPF, so we can minimize the size of the routing table in OSPF stub. Here, what is the requirement of EIGRP stub? Let's talk about scenario. So I have collection of routers, for example, R1, R2, R3, R4, R5, and R6.
Yes.
Now here we have source and here we have, for example, destination. And to reach the source to destination, we have some cost. For example, I'm using the random number 2000, 1000, here 3000, here 2000, here 4000, 5000, 6000. Now we have multiple routes to reach from source to destination. We can go via R1, R2, and R6. R6. Now we can go via R1, R3, R6. We can go via R1, R4, R5, and R6. Now let's talk about FD and AD concept. So this side we have FD value. This is feasible distance. This is advertised distance. So now FD value is 3000. AD value is 1000. This side FD value is 5000 and AD value is 2000, right? Do you see? If you remember our EIGR, yes. Any question?
Yeah. For FD, FD is the sum of cost
Yes.
to reach destination.
Total cost from source to destination.
Destination. Yeah. Then the
AD is what?
AG
Neighbor to destination total cost.
neighbor.
Neighbor to
Okay.
destination. So R1 neighbor is R3 and neighbor to
Yeah.
destination total cost is 2000.
Yes.
Okay. So
Yeah.
now if you remember here this side we have 15,000. This side we have 11,000. So as per this design, this route on this side we have least cost. We have least cost. So this route will install into the routing table. Okay, into the routing table. But if you remember our feasibility condition, if I'm looking for second best route in EIGRP protocol, for second best route in EIGRP protocol, then you need to satisfy feasibility condition. And what is feasibility condition? Best route,
Yes.
FD value should be greater than second best
Second best route.
AD value, right?
AD value. Yeah.
AD value. So now best route FD value, this one is a best route. This route FD value is 3000. 3000. Now second best route. This one is looking for second. This one is looking like second best route. And via this side, AD value is 2000. So no problem. 3000 is greater than 2000. So yes, this route will maintain. This route will maintain as a second best route.
Second best route.
Second best route,
Yes.
right? So in case
Yeah.
of this one is your best route, this one is your second best route. So in case best route goes down, best route goes down, then router will not send any EIGRP query packet to any route because this R1 has a second best route because feasibility conditions satisfy here. That's why this R1 has second best route. Then, so when best route goes down, no problem. Second best route will become best route, right? Do you see?
Yes. Right.
Okay. So now, if feasibility conditions satisfy, we have second best route. Now, in case, if feasibility condition not satisfy, feasibility condition not satisfy. Here we have, for example, 4000. So this one is 7000. This one is 4000. So 3000 is not greater than, it's not greater than 4000, right? So
Yeah.
now into this scenario, feasibility condition not satisfy. So this R1 has only, this R1 has only best route, right? Do you see?
Yes.
This
Yes.
R1 does not have any any second best route. This R1 has only best route, only best route. Feasibility condition not satisfy here. So this R1 does
Mm.
not have any second best route. Clear my point, do you see?
Yes. Yeah.
Now, we are familiar with this concept. We are familiar with this concept. Now, so in this case, if best route goes down, my point is best route goes down, then router will send EIGRP query packet to all EIGRP connected routers. No problem.
Mm.
R1 is sending. R1 is sending EIGRP query packet to this router. Perfect, no problem, because this side we have destination. R1 is sending EIGRP query packet to this router, no problem. But in case I'm working in a design, wait, in case, this is the condition. If I'm working in a design where we have routers this side, routers this side, they are connected with each other. Now, my point is, UNC, can you hear me? My
Yes.
point is R1 is sending EIGRP query packet to this side, no problem, because this side we have destination. He's sending EIGRP query packet this side, perfect. This side, perfect, no problem. But I told you, when a router does not have any second best route, and when best route goes down, it will send EIGRP query packet to all EIGRP connected routers. So R1 will send query packet. R1 will send query packet to this router also, this router, and this router. When this router will receive query packet, it will send this query packet to this router. And when this router will receive query packet, it will send to this side and this side. Yes or no? You can see.
Yes. Come
Clear my
on.
point? This
Come on.
will create query loop. This will create
Oh.
query loop in your network.
Okay.
Why we have query loop this side? Why? Because destination we have this side. If R1 is sending query packet to R3, sending to query packet to R4, perfect, no problem. R1 is looking for next best route. He's
Mm-hmm.
sending query packet to R3, R4, perfect, no problem, because this side we have destination.
Yeah.
Why we have query packet this side? And this can create query loop in your network. That's why
Mm.
into this design, this type of design is called hub and spoke topology, UNC. Okay.
Hub,
This
hub
type
and
of
spoke.
design is called what? Hub and spoke design. Hub and spoke means what? Into this design, I'm talking about this design, this one. Into this design, R1 is acting as a hub router, okay?
Okay.
And they all are connected to this hub router. So these routers are called what? Spoke device. Spoke 1, spoke 2 device, spoke 3, and spoke 4. So that's why you can say hub and spoke topology. Hub and spoke topology. So if you are working in hub and spoke topology, then if you want to limit EIGRP query packet, then you need to use EIGRP, you need to use these routers. You need to use these routers as a EIGRP stub router.
Okay.
EIGRP stub router. If if these routers are acting as a EIGRP stub router, so they will send a update to R1. They will send a update to R1. Hello, Mr. R1. We are stub router. Don't send any EIGRP query packet. Clear my point? Do you see? What is the benefit of EIGRP stub? What is the benefit? We can limit the query packet. Clear now my point? Do you see?
Yes.
We can we
Yes.
can
Yeah.
we can limit the query packet. Let's talk about stub routing is one way to limit queries, EIGRP queries. A stub router is one that is connected to no more than two neighbors. Should neighbor be a transit router? Yes. These routers, these routers are not transit router. This R1 is a
Okay.
transit router. R1 is a transit router. So now, wait. EIGRP stub routing feature improve network stability, resource utilization, and stub routing is commonly used. This topic you can use. This stub routing is commonly used in only hub and spoke topology. So in case if you are working in a stub and hub and spoke topology, you can go with EIGRP stub concept. I hope the concept is clear for you.
Yeah. Almost clear.
Okay. Can we go for
Almost clear.
implementation? Rest you can get an
Yes.
idea in practical implementation. Wait.
Yeah.
Let's create a design. Wait.
Mm.
I'm creating some loop back here. 3.3.2.1, 3.3.3.1 slash 24, 192, 168, 30.1 slash 24. Okay, let's configure EIGRP. Let's configure EIGRP into this design. We are trying to advertise our interfaces, networks in EIGRP protocol. Wait. router.
Okay.
Let's create one loop back here on R1. So 1 dot 1 dot 1 dot 1. I'm creating two loop back here. Interface loop back 1, 192, 10.1 mask. Show IP interface brief.
Okay. 10.
Let's create loop. Let's advertise our loopback interface. 192.168.10.0 wildcard mask. No auto summary. Let's move on R2. Interface fast Ethernet 0/0 10.1.12.2. No shutdown. Interface fast Ethernet 0/1 10.1.23.1. Mask no shutdown. Show IP interface brief. Router ARGRP 10.1.12.2. Mask no shutdown. Wait. Show IP interface brief. Let's move on R3.
The protocol, you just set
Yes, yes, yes,
one
yes,
route.
yes, yes. Thank you. Router ARGRP 10.1.3.0 wildcard mask. No auto summary. Let's go to
Okay.
R3 0/1 10.1.23.2 mask. No shutdown. Loopback we can create loopback interface. T.3.0.1 mask. Loopback 1, loopback 2, loopback 3, loopback 4. 30.1. 3.3.1.1, 2.1, and 3.1. Let's create loopback interfaces here on R3. Show IP interface brief. Router
Yes.
EIGRP 10, network 10.1.23.0, wildcard mask 3.3. Okay. Network 192.168.30.0, wildcard mask, no auto summary. And now what I'm doing, 3.3.0.1. These loopback interfaces,
Yeah.
these loopback interfaces, I want to summarize. I want to send a summary address to R2, okay? But before this, let's advertise it. Let's advertise in EIGRP. Network 3.3.0.0, wildcard mask. Now let's verify our routing table. Let's verify our route information, show IP route EIGRP. So yes, we are receiving all the routes from R1 and R3, right, Juvency?
Yes.
Now, in case, if I want to use this router as a stub router, in case, for example, this is your
Okay.
transit router, you are working in
Transit.
a hub and spoke topology, you have multiple routers in this side, hub and spoke topology, you are working in a hub and spoke topology, and I want to use these routers as a stub router. Then what is the command? Right now, I'm receiving all the information from R1 and from R3C. R3
Mm.
loopback information. Now, let's go to R3 and I want to use this router as a AIGRP stub. You can
Okay.
go in protocol, you can go in protocol and command is what? AIGRP stub. Done. You can press enter. You can press enter here, no problem. But yes, we have multiple options. We have multiple options in stub router
Receive
configuration.
only, connect, start.
We can discuss this, but let's go with the this command first. EIGRP stub. You can press enter. You can press enter. Now this router is a EIGRP stub router now. Now if you go and check on R2, you can verify what information you are getting. Okay, before this, let's create one more loop back. Let's create one more loop back. Loop back 10, for example. 33.33.33.33 mask. And this loopback interface, I want to advertise in RIP protocol. Router RIP version 2.
Okay.
No auto summary. And this RIP protocol, I'm trying to redistribute in EIGRP. So redistribute RIP protocol, metric 100, 100, 255, 255, 1500. So now you can check it on R2.
Metrics.
You can check on R2. We are using this router. Wait, we are using this router as a stub router. You can see,
Stop
right?
router. Yes.
So what information R3 is sending? What information R3 is sending to R2? What information? Because this router is now stub router. What information is sharing? See, he's sending. Let's verify root information. So this R2, R3 is sending only EIGRP roots. These are what? EIGRP roots. 192.168.30.0. Only EIGRP root. So if you press enter, if you go with the EIGRP stub command, if you go with only EIGRP stub command, so the default is what? Default is connected root
Connected
and summary
and
root.
summary.
So this
Okay.
router will send only connected network root information and summary information. Only. He is not sending redistributed routes. We are using redistribution, but R3 is not sending any external information with R2. Now, in case, let's go to EIGRP, and I'm not using this router. I'm not using this router as a stub. No EIGRP
No.
stub.
Stop. Okay.
So I'm not using any stub command here. If you go and check
Mm.
what information I'm getting this time, so I'm getting all the information, right? See,
All the information.
external route. Let's use summary address command. Interface fast Ethernet 0/1. IP summary address. EIGRP 10. 3.3.0.0. 255, 255, 252.0. This is summary address. Now let's verify. Yes, this R1, sorry, this
Mm.
R2 is receiving external route,
External.
summary route, and EIGRP routes. Yes. Now in case, if I'm using this router as a stub router again, EIGRP stub. So what information R3 is setting? So the default is what? Default is summary address and EIGRP.
AIGRP. Okay.
Now we have other options. We have other options here. Receive only, connected, static, summary. So in stub router, I can use some options. Let's talk about each option one by one. So I'm not using this router as a stub. You can verify now. You can verify you are receiving all the routes. Now,
Okay.
let's go here. And now router EIGRP 10. EIGRP stub. Now this time I'm using what? I'm using receive only.
Receive
Receive
only.
only. I'm using this option in EIGRP stub. Receive only. Wait. Receive only. You can press enter. You can press enter. Now let's verify routes information on R3. So R3 is receiving route information from R1. From R1
Oh,
output is
okay.
receiving the route. Now what about R2? R2 is not receiving any update,
Any any update.
any
Yeah.
update from R3. See?
Mm.
So
Because you
in case if I'm trying to verify my connectivity with 1.1.1, I am getting reply. And if I'm trying to verify my root information, if I'm trying to verify my connectivity with 0.1, I cannot ping because R1 is not
mm.
receiving any root information from R3, right? But see,
Okay.
R3 can ping. So R3 is
Mm.
saying, I am a stub router and I don't have anything.
And
I don't have any root.
okay.
So that's why I'm
That
using
means
EIGRP stub receive only. That's why I'm using EIGRP stub
receive
receive
only,
only.
yeah.
It means I'm only trying to receive the roots.
Mm.
Okay, I
But
don't
not
have any
share.
roots. That's why I'm not using any other option. I have only connected networks. I don't have any roots. That's why I'm using this option. Receive only. Clear my
Okay.
point?
Yeah.
Now let's go to EIGRP protocol again, and I'm not using this EIGRP stub receive only command. No.
Mm.
So now you can check. You can check is receiving all the information. Wait, receiving all the information. Now, next point, EIGRP stub. Now we can go with other option. Connected,
Connect.
connected. If I'm using connected option, so R3 will send all EIGRP connected route information. External route is not connected with EIGRP. External route is an external route. So you can check now. This R3 is sending only EIGRP routes, not summary routes. See, this is what
Mm.
connected routes. This is what connected route. R3 is not sending external route information.
External connection.
Now, in case if I'm going with other option, EIGRP stub question mark, you can go with summary option. Summary is what? If I'm using EIGRP stub summary, so you can check
We
now.
we just show the summary
Yes,
summary.
only summary route, only summary route.
Mm.
See,
Okay.
only
Mm.
summary routes. Now you can go with
Static.
EIGRP stub. Now you can go with static. If you have any static route, you can go with static. So we are
Okay.
now familiar with connected option. Receive leak map is not our topic right now. Now receive only, yes.
Receive.
Redistributed, static, and summary. These options are available in EIGRP stub. And this is our
Oh,
topic. I hope it's clear for you.
yes. Yes, clear.
Okay, so this is our EIGRP protocol discussion. Now, REST EIGRP concept, OSPF concept, we can discuss in route filtering method. Route filtering. So now we are trying to focus on route filtering method. These methods we are using in protocols. It means we will work in protocols again, EIGRP, OSPF, RIP, in protocols again, and in protocols, we can control our routing update. We can control our routing update with these route filtering method, passive interface, distribution list, prefix list, route map, and policy based routing. UNC.
Yes.
Clear now?
Yes, it's clear.
Route filtering, let's start tomorrow, UNC. Okay?
Okay.
Route filtering. Any
But
question?
yeah, the question is, I'm not. I didn't receive video of last session,
Last
and
session video,
also,
UNC.
yeah, also when I check my video, I found that many session, 2 or 3 session, I didn't receive. I don't know if you have one file where you are putting. our session video.
Let me check. Give me 2 minutes. Give me 2 minutes.